Hey, Natty Sci students, if you missed class on Friday of last week or today, which is Monday, February 22nd, I just wanted to catch you up on what we were discussing in class with regards to how energy can move into different locations and how we can experience it in human beings in different ways. And as an example, the key difference that we talked about in class is the distinction between stored energy and the energy of motion. And this sheet, the model rocket flight profile, has different stages of that flight labeled with GPE, which is short for gravitational potential energy, and KE, which is short for kinetic energy. And the expectation of what we got to by the end of the 80-minute section was that you would be able to label a diagram like this, because looking forward on Wednesday or Thursday of this week, you will be expected to write an essay using roller coasters as an example to demonstrate your understanding of potential and kinetic energy and their trade-offs. So I'm going to switch to a key that we're going to be using for this example, as well as descriptions of how changes in the different forms of energy result in a different focus for how we label these. So let's start up top with the key. Question is, what goes in the blanks? Well, here are your four options. Your options are maximum, greatest, zero, none of that form of energy, up arrow, increasing or getting bigger, or down arrow, decreasing and getting smaller. And then here are the different forms of energy that we're going to label on the rocket launch example. Kinetic energy, the energy of motion. Gravitational potential energy, the energy of gravity of height. We're not going to see elastic potential energy on this sheet that I'm showing in this video, but just want to point out that for the marble launch challenge, we had a spring-loaded marble launcher, and that would be an example of elastic potential energy. And then one we're going to see right away is chemical potential energy. And so each of these four different forms of energy, it shows here what you can think about in order to understand what's happening with these different forms of energy. So for example, starting with kinetic energy. Kinetic energy is all about speed. When speed increases, kinetic energy increases. When speed decreases, kinetic energy decreases. Now moving on to the forms of stored energy. Kinetic energy is the energy of motion. These are ways in which energy can be stored. GPE is gravitational potential energy. To decide on this, we're going to think about the height. As height increases, gravitational potential energy increases. As height decreases, gravitational potential energy decreases. The more a spring is compressed, like from the marble launch example, the greater the elastic potential energy. The less a spring is compressed, the less the elastic potential energy. In class, speaking of elastic potential energy, we also talked about how compressed air can also be an example of elastic potential energy. So for example, a human cannon, when they get launched out of that human cannon, it's actually not an explosion, it is a releasing of compressed air that is elastic potential energy. And then last but certainly not least, chemical potential energy is all about the energy of explosives or things being on fire or the breaking of chemical bonds in the case of biology. So when there is no release of stored energy, there's no explosion, that would be maximum chemical potential energy. And when it is released in either an explosion or fire or food being broken down in your body, that would be zero chemical potential energy. So let's go ahead and label this example. This is a model rocket flight example, and we'll start down here at the bottom. I'm going to add one thing to this diagram. I'm going to add CPE, because at the start of this example, we are assuming that the rocket is still on the ground. It has not been launched yet. And this example, this rationale or series of logical steps that we're going to go through here applies equally to a marble launch, a roller coaster, a slingshot, the egg drop device. All those things all follow these similar steps. So before the rocket launches, our chemical potential energy is at a maximum because we have all that energy stored inside the engine. I'll go ahead and show you an example of what that engine looks like that we're going to put inside of our rockets when we launch them Q4. This is a Series A83 engine from Estes, and this is what we use to launch off of the baseball field later on in quarter 4, and so that's something to look forward to. We couldn't do it during this quarter because we don't have enough time, unfortunately, but I built time into the schedule during quarter 4 to do that. Kinetic energy, well, if something isn't moving, it doesn't have any of the energy of motion. The energy is in different forms. In this case, it's stored as chemical potential energy, and if our rocket is still on the ground, our gravitational potential energy is 0. Okay? After that rocket takes up, the height is increasing, so our energy stored in gravity is increasing. For kinetic energy, it really depends upon where exactly on this diagram you're talking about. If you're talking about down here right at the launch, you could argue that the kinetic energy is increasing because the rocket's getting faster as that engine spits out gases. As you get closer to the top up here, we would say that the kinetic energy is decreasing because we're getting closer and closer to the top of its flight, and as a result of that, it's going to be slowing down as gravity pulls on it. Now, when it gets to the very tippy top up here, that's the maximum gravitational potential energy because that's the maximum height that it will have, and its kinetic energy is 0 because for a split second up here, it is not moving. When you throw something up into the air, once gravity is allowed to fully take over, you will get to a situation where you have no motion for a split second. Now, as that rocket continues to fall, it's falling, it's being pulled towards the center of the Earth, so gravitational potential energy is decreasing, height is decreasing. For kinetic energy, it depends upon what part you're going to focus on. Gravity is certainly causing the kinetic energy to increase. Air resistance from the parachute is causing the kinetic energy to increase, and it's usually gravity that wins out for these two. And so we would say that the kinetic energy is increasing as it falls, because even though the parachute slows it down, it is definitely getting faster as a result of the pull of gravity. Okay, remember, parachutes are not a sure thing. We learned that when we were doing the egg drops. Once it gets on the ground, its height is 0, so its gravitational potential energy is 0. Once it gets on the ground, it's not moving anymore, so its kinetic energy is 0. If you have any questions about kinetic or gravitational potential energy or energy that is stored in the form of elastic potential energy for a spring or chemical potential energy for the rocket engine, please let us know, because your summative experience for kinetic and potential energy is going to be you describing to us in the essay how a roller coaster works, and the same principles and steps will be followed for you deciding on that for the roller coaster. Have a great day.